4.2 is isosceles and equilateral triangles. In this diagram right here, we're going to be looking at that. If you notice that BC, segment BC, that's a C.
That's an A.
That's a C.
Oh. Man, good enough.
This pen likes to get jumpy. Okay, so segment BC is congruent. What's congruent mean?
Same measurement. Equal.
Same measurement. Okay, so when the difference between congruent and equal, and I guess I wasn't being very clear with this, and I need to be more clear. Denzel, your phone needs to be put away. Like away. I don't want to see it, please. Okay, things are congruent, numbers are equal. Does that make sense?
No.
So a thing would be a side of a triangle, right? But if I actually had the measurement of it, they would be equal. So things are congruent, measurements, actual numbers are equal. So segment BC is congruent to what? Look at the picture.
AC.
BC. How? Because it has what?
Oh.
The tick marks.
Oh my goodness.
So BC is congruent to BA. Okay? And the tick marks tell me that those two things are congruent. So there is a rigid motion that maps BC onto BA. What would that be?
Final.
What rigid motion would map this onto this? Reflection. Okay? The angle bisector, now we've talked about bisectors. What does a bisector do?
Cuts in half.
Cuts it in half. And since it's an angle bisector, it's cutting angle B in half, isn't it? So if it's cutting angle B, so it's BD here. And this is not a segment, it is a line. And remember, for lines, I put arrows. How do I know this is a line?
Because it never ends.
Because it never ends, it has arrows. So the angle bisector BD divides ABC so that angle CAD, you should just look at the picture, is congruent. So C,
You mean CDA?
yes. That is not right. That's why I said I should look at the picture.
Yeah, you probably should.
Okay, so let's do that again. So angle, yeah, CBD is congruent to what angle?
BBD.
BBD.
BBC.
What's BBD?
Oh, I'm having a bad day. I said it right and wrote it wrong.
What's in your water bottle?
Water. Okay, so CBD, okay, CBD is congruent to what angle?
BBC.
ABD.
You don't know anything about that, would you?
No. I know.
Now, could I have named it DBA?
Yeah.
Yeah, but the B has to be at the vertex, right? The B has to be in the middle. Hey,
This,
gentlemen, it's weather outside. Focus in here.
was it snow?
Chance.
Is that my dad? Oh yeah.
Come on, guys. Okay. Since the reflection maps triangle BCD to BAD, to triangle BAD, so this whole triangle maps it onto this triangle, right? And those measures are equal. Therefore, triangle, we're just going to say triangles now, BCD is congruent to triangle BAD. So we've taken this all and moved it all around so we can use it to come up with our two theorems here. So what that leads us to is the isosceles triangle theorem. If you have a highlighter, you might want to highlight the name or whatever. The isosceles triangle theorem says if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So if you look at the picture here, it's showing that AB and BC are congruent. So that would mean that BAC and BCA are also congruent.
How do you get that again? I'm confused.
This is just the theorem. You don't get it. It's the rule. It says if two sides of the triangle are congruent, so AB and BC are congruent. They show me that. Then the angles opposite those two sides are congruent. So that would make it the base angles. This angle up here is called the vertex angle. And these two are called base angles. Now, sometimes the base angles are up top, but the base angles are the two angles that are equal. Now we have the converse. Now the converse means we can just use it the other way. We say exactly the same thing but the opposite direction. So the converse says if two angles are equal, so look at my picture to see how the two angles are equal. See that?
Mm-hmm.
So if two angles are equal of a triangle, if two angles of a triangle are congruent, then the sides, what? Opposite those angles are congruent. So that means that AB and BC are congruent.
So what's the difference between the two theorems?
Well, the first one is talking about the sides, yes?
Yeah.
And the second one are talking about the
Oh.
angles. So if I know the two sides are equal, then the two angles have to be equal. If I know the two angles are equal, the two sides have to be equal. This is called an if or an only if statement. I can read it frontwards and backwards and it works. So we're going to use those facts today in solving problems. So an architect is designing a community park between North 1st Street and South 1st Street. The pathway around either side of the pool will be equal length. So it tells me already that this side is equal to that side, or they are congruent, correct?
Yes.
Okay, it tells me this angle here is 50. The landscaping, to protect the landscaping and to minimize erosion, the architect will place a triangular section of triangular cobblestone at the corners along Park Plaza. So that would be E and F. What angle measure should the architect specify for the corners in her design?
50.
No, 50 is this one.
Yeah, but wouldn't it be congruent though to the other one?
No, because my theorem says if the two sides are congruent,
Oh.
then the base angles are congruent, correct? So we know, what we know now are angle E and F are congruent, yes?
Mm-hmm.
So angle E is congruent to angle F. We also know that angle D is what?
Congruent to F.
No,
No.
angle D equals what? No, angle D is
50.
50. Angle D is 50 degrees.
Yeah.
So I need to figure out what E and F are.
65. Yeah, 65.
How?
Because 180 minus.
Okay, so we're going to take it. You're going to take 180 minus 50 will give me 130, correct?
Divide by 2.
Okay, 130, and that tells me I got 130 left for E and F, right? And since E and F are congruent, I can just divide it by 2.
It'd be,
So they are 65 degrees. You've done problems like this already, but they didn't just say they were an isosceles triangle. They just put the little things there that you knew that the angles. Now you have to know the angles are equal, or congruent, excuse me, because they are isosceles triangles. So we need to find the value of x, and then we're also going to find the rest of the angles as well.
what?
So I know these two
How
sides
28?
are congruent.
No, it's not 28.
So what else do I know?
Down the bottom, 2 vertices.
The other, this and this are congruent, yes.
So,
So this has to be 28 also.
yep.
So what'd you say, Savannah? Okay, so 28 and 28 is 56. 180, why are we taking 180 minus 56? Okay, because we need to find out what the remainder angle is, right? So 124? So 124 degrees equals what? Equals what?
The 5, not the
5x plus 9. And then I just need to solve the equation, correct? So I subtract 9. So I get 115 equals 5x. And what, Bryce?
Minus 5 from the other side.
It's multiplication.
Oh, you divide 115 by 5.
I divide 115 by 5. So 5 goes into 11 twice with 1 left over, and 5 goes into 15 3.
degrees.
So x is 23. X is not 23 degrees, though, is it? It is just 23. Now I'm going to check my work by plugging it back in here, and I better get 124, right?
Yep.
Okay, so 5 times 23 plus 5. So 5, carry 1, 115, plus 9 is 23. So we're good. So on the next triangle, they don't give me the side lengths, they give me the what? The bases. But they tell me that the two sides are congruent. So if the two sides are congruent, what do I have to know?
Only one of the bases.
You have to add them. No subtract them.
The base angles are congruent, meaning they're what?
All get it.
Equal. So what do I have to do with these two equations? Set them, not combine them. You just said they were equal, so I need to set them what? Equal. This negative 4x plus 9 has to equal 8x minus 3, correct?
Mhm.
So I just negative 4x plus 9 equals 8x minus 3. So I'm going to add 4x and add 3. So I get 12 equals 12x. Divide by 12 and x equals 1. What do each of the angles equal? So negative 4 times 1 plus 9 is 5. And the other one better equal 5 also, right? So 8 times 1 minus 3 equals 5. So each of these angles equals 5 degrees. What does this angle equal? 170. So
And
all
how does
they
that equal 5 degrees?
You plugged it back in, didn't you?
plugged it back into what they gave me.
But how does
This no pictures to scale. You never touched your picture. You only touched your number. And the other thing is what the reason I showed you is the problem only asked for what? X.
Get it.
But could they ask you to have found all the angles and all that kind of stuff?
No, because they're not your daddy.
Yes.
How
So you need to make sure, just a second, Devin, that you are reading the directions and answering what they ask. Yes, Devin?
How did you know where the pipe is?
Because we have x is 1, right?
Yeah.
So I just plugged it back into here. So I have negative 4 times 1 plus 9 is 5. Okay, so we're gonna have angles and we're gonna get to sides. Denzel, I need your phone, please. Thank you. So I know that these two angles are equal. So what do I also know?
If they add up to the, no.
No.
So you gotta-
If these angles are congruent, what do I know about these sides?
Oh, the congruent.
They're congruent. Okay, now this one says find x and all the side lengths. So if I know that 20 plus x plus 20 is congruent to 8x over 3, then I need to set them what to each other? Equal. So I have 8 plus 20 equals 8x over 3. So you gotta get rid of that 3, right? Remember that this is one whole thing over here. So I'm going to multiply both sides by 3. So over here it reduces and I'm left with 8x. What do I have to do with this 3? I have to distribute it. Good job. So I have 3 times x is 3x plus
60
60
equals 8.
equals 8x. And hopefully you would subtract 3x, right?
Yeah.
So I get 60 equals 5x. And then divide by 5. So x equals 12. So I found x. Now what does it say to do? Okay, so find everything. So I just need 12. So 6 times 12 minus 12. Okay, so 6 times 12 is? You could just do 6 times 5, couldn't you? Because you're going to take 1 away, but either way. So a 72 minus 12 is 60. And then 12 plus 20 is
34. No, 32.
32. Now over here I got 8 times 12 over 3. But I don't have to take 8 times 12 and divide by 3. Can't I divide 12 by 3? Okay, so 3 goes into 12 how many times? 4. And 4 times 8 is 32. And we should have known that that was going to come out to be there. It's a check, right? To see if my work is right.
Yup.
What's the top answer again? 70?
72 minus 12, so it's 60. So I've got 8x minus 1, 4x plus 5, 2x plus 11, and I know my two angles right here are congruent. So what do I also know are congruent?
The length.
Silence are.
These are congruent to each other, right?
Yep.
So I need to do what with them?
Add them. Oh, make
Set
them
them
equal.
equal. Okay, so you guys do it. I'll give you a minute. I'll give you more than a minute, but then I'll start. Remember, you're finding x and all the side lengths. equal 3 halves?
No, but I see where it belongs though.
Okay. So you should have x equals 3 halves. But there's a good thing about that in the numbers they gave me. Anyone not get, you found out what you did, Judy? Anybody else not get that and not know what they did? Okay, the reason why I use 3 halves is because I don't want to use 1.5, which is essentially 15. I would rather divide by 2, multiply by 3. So now I plug it in, correct?
No.
So I have 8 times 3 halves minus 1. Well, this is 8 over 1, isn't it? So does 2 go into 8?
Yeah.
How many times? 4. So 4 times 3 is 12 minus 1 is 11. Even though it's a fraction, it wasn't bad, was it?
Nope.
Okay, so the next one, I'm going to plug it in here. So I have 2 times 3 halves
Be 6 when it's
plus 11. So 2 goes into 2
1.
once. So I get 3 plus 11 is 14. Now the other one would be JD if you're
Yeah.
doing that. 4 times 3 halves plus 5. My answer better come out to be what when I'm done?
11.
11. So 2 goes into 4 twice. 2 times 3 is 6 plus 5 is 11. So we got 11, 11, 14, and X. So we had 4 answers there, right?
Don't all triangles add up to 180?
But it's
The
not
angles, these are sides.
I
But
thought
yes,
the same
you're right.
thing.
Can I answer anything about the angles? Could I tell you the angles here?
Probably.
They don't give me any angle measurements, do they?
No.
Without at least one angle measurement, can I do anything with
No.
that? No. So they would have to give me, if they gave me one of those angles, could I do the rest? Yeah. Okay, I'm going to erase down here because I wrote over my line. So we have another theorem that we're going to use. It is the isosceles triangle angle bisector theorem. So what is an angle bisector?
Cuts in half.
Cuts the angle exactly in half, right? So it says if a line or segment, get on my thing, segment bisects the vertex. Again, bisects means what?
Cut in half.
Cut in half. The vertex angle of an isosceles triangle, then it is also the perpendicular bisector of the opposite side. Okay, so if a line or segment bisects the vertex angle of an isosceles triangle, and this is important that it's a what triangle? Isosceles. It doesn't happen with every triangle. Brian, can I have your phone now, please?
Maybe don't be on your phone.
He was texting his mom.
I don't care.
Well, his
You
mom
didn't
does.
ask to be on the phone.
I did.
Okay. If it's an isosceles triangle, it is a perpendicular bisector. First of all, what's perpendicular mean? The two lines meet at a what?
90.
90-degree angle. Bisector means
Cut it
cuts
in
it in half. So if you look at the picture, BD is the perpendicular bisector, so it's a right angle. And these two pieces of the base are equal. Now that I've done that, how many triangles are in this picture?
Those.
3.
3.
She said, Mom, what I done?
I have 2 right triangles, correct?
Yeah.
And an isosceles. Did I give you something
Oh.
yesterday that can solve any right triangle? Yes.
Yes.
You got the Pythagorean theorem yesterday that can solve any right triangle. So by using that, I can solve for parts of it just because I know it. Yes.
Can I use Russian?
Yes, quickly.
Can I use Russian?
Okay. So now we have to decide something here. It says a fabricated house is divided to a foundation in 2 symmetric halves and is assembled on site. Along the planned route of the site, the truck must go under a bridge that's clearance is 17 feet. Should the truck plan a different route for delivering the house? Explain.
Sure.
So I need to find out how high it is, right?
Mhm.
So the picture tells me from the bottom to here is 10 feet. I know the base is 28, so if this is 28 here, is this also 28 up here?
Yes.
Yeah.
Yes. Okay. But I need to figure out what this height is, don't I? So I can add it. So we're going to draw that picture over here so we can have a little bit better insight to what we have. So we know this whole thing is 28, yes? And they're going to cut it in half. So what did I just make?
A bisector.
3 triangles.
3 triangles, 2 of them being right. It was an angle bisector, right? And I know this is what over here? 16. And this is 16. And so these 2 angles have to be the same, yes?
Yes.
Okay, just some added information, but that's not really what we need, right?
It is.
Okay, so if this is a perpendicular bisector, what do I know about this and this?
They're equal.
They're equal. And the whole thing was 28.
So you divide by 2.
So divide it by 2 and get
14.
14. So this is 14 and this is 14. So I need this length right here, don't I?
Yeah.
So I can add it to 10. So I'm going to have 10 plus x, and that has to be less than 17, doesn't it?
Yes.
Wouldn't it be 16?
Well, it would. Well, it says the clearance is 17, so we are just yes. We're not. I'm not going under it unless it's 16. But that's the problem. Yes,
Where are you getting the 10 from?
the 10 right here on the picture.
Okay.
It says from here to here is 10.
Okay.
Okay, so I know the 10. I mean, that's a good question. I know the 10, and I need to figure out x. So I have a right triangle here, don't I?
Yes.
What parts of that right triangle do I have?
The bases.
I have a
No.
leg,
You have a leg and then the
hypotenuse. So using Pythagorean theorem, it's going to be 16 squared equals 16 squared equals 14 squared plus x squared, correct? The 2 legs squared?
Yep.
So I'm going to have to subtract 14 from 16 squared. So 16 squared minus 14 squared equals x squared. So what is 16 squared?
256.
256. Wonderful transition to you have a squares and cubes quiz. It's worth 35 points. It's a big point value in this quarter, so we need to get it in. We're studying for that. It's this week. And 14 squared is
196.
196. So 0, 6, 60?
Yeah.
So I have 60 equals x squared. It's not 60, is it? Yeah, it is. Equals x squared. So I have to take the what?
You have to make it small.
I have to take the square root, yes. Now, this isn't a problem. First of all, it's 2 times 3 times 10, which there's no perfect squares in 60, so I can't reduce that, right? So if I told the driver, well, your height is 10 plus the square root of 60 feet. Does that make any sense to the driver? No. I need to get an approximation for that, don't I? So I need to use a calculator. So when I approximate that in a calculator, so x is approximately 7.071 feet. And I went out some decimal places because I need to go out some decimal places when I'm talking about taking a house under a bridge, correct? So I have 10 plus 7.071, so it's going to be 17.071 feet. That is not less
Well, usually I have a problem.
than 17, is it?
Huh.
So should he take a different route?
Yes.
Yes. He should definitely take a different route. Now, JD said, well, it needs to be under 16. Yeah, I definitely, unless it was under 16, would not be going under that bridge. Because what happens to roads?
They fork.
do they warp? And there's high and low spots, and there's different things going on.
It goes to the
And I don't
chimney.
want to take a house under a bridge and scrape it the entire way, or get stuck.
It goes for chimney.
Yes.
Usually they account for that in the bridge height, so it's higher than it says it is.
Right. But still, I'm not risking it. Have you guys ever gone under, like, by a bridge and seen something stuck like that?
No, I've seen it
I
close,
have.
though.
It was on a big river. I don't even remember which one, but it was one of those trestle bridges, and it got caught. It got in like a quarter of the way and got stuck.
What
Can't
was
deal
that
with
stuff?
that.
What?
What was that stuff?
A semi. It was carrying something, and it got about a quarter of the way and got stuck. So they had to come in, and you guys know how they get it unstuck?
They just pull
They
it
take
out.
off the tile.
No, they can't pull it out. They have to lower the tires, and then back it up,
Don't
basically.
you get fined for that?
Yeah, you get fined big
Yeah, I
time
thought-
for that.
That's what I thought you did.
Yeah.
Where did it get stuck? In a garage or?
No,
Under a
on a
bridge.
trestle bridge. Yeah, it was. Yeah, because you get fined big time
Yeah,
for that.
I knew that for it.
Okay, So now, what is M? What is the measure of RSQ? So RSQ right here.
Well, you have
Okay, and you know P. What is the measure of PR? So I know that these two sides are congruent.
mm-hmm.
So what do I know about angle R?
31 degrees.
It's 31 degrees, because angle R would be congruent to angle P, right?
Yeah.
So this is 31 degrees.
Mhm.
So if we have 31 and 31, we have a total of
35.
About 62.
62. How'd you get 35?
Oh, I thought you added a full second.
No.
My bad.
So I'm going to take 180 minus 62, right? So I get 8, 7, 17. Yeah, not 17. So 118 is angle RSQ. Yes? No, is RSQ half? What angle did we just find? We did not find. What did we find?
You?
PSR. Okay, so we found PSR. So if I want RSQ right here, I divide by 2 because it's an angle bisector. How do I know it's an angle bisector?
Because it cuts in half.
Because it cuts it in half, and it should have. The picture should have had this.
Is P equivalent to all you said?
Yes.
Okay.
Because those are the base angles.
Okay.
Okay, so I divide this by 2, and 2 goes into 10, 5, 9. So 59 degrees is equal to angle RSQ. And now I need to find what? PR? Oh, well, if I know this is 4 from here to here, so PR is 4 times 2, which would be 8.
I know.
I'm
Laura,
confused.
Couldn't you also just do 90 plus 31 and take that 90?
Yeah.
I didn't do it wrong.
Oh, I just did the wrong one. So she just asked, couldn't I have done, this is 90, right?
Mhm.
Could I have done, and then actually, I wouldn't even take 90 times 180. If this is 90, these two angles have to equal 90, yes? So I would have just done 90 minus 31, which would have been 59. There's many ways to do it. I was just using what we had done today. Yes, sir.
I'm confused how you got. I know how you got 118. You added the sides.
No, I added the angles,
Yeah.
and I subtracted them from 180.
You
Because
got 118, and then how do you get 59?
I divided it by 2 because because 118 is the whole,
Okay, gotcha. And then
and that's bisected, so it's half of that.
so 59
It's half of 118.
Okay, and then what do you get the 8 at?
Okay, this right here
Yeah.
is 4, and this
Oh,
and this are the same.
gotcha.
So 2 times 4 is 8.